In section 4.3, we look at phase shift. Now, a phase shift is just a horizontal shift of the graph. But when we're talking about the graphs of trig functions, we call it a phase shift. So the format of the equations we'll be seeing here are going to be y equals a times the sine of bx plus c, and y equals a times the cosine of bx plus c. And we already know that the absolute value of a is equal to the amplitude of the trig function. We know that 2 pi divided by b is equal to the period of the function. And now the question is, what does the value c do here? And I'll go ahead and write it down just to get it out there, but that's basically going to contribute to a horizontal shift of the graph. And so that phase shift, as we call it, ends up being negative c divided by b. And if you're feeling a little bit overwhelmed with all of this, don't worry too much about this phase shift. I'm going to show you another way to think about it in just a little bit. But first, we start with a simple example. We would like to graph the function y equals the sine of the quantity x plus pi over 2. So if I just take this at face value, I want you to notice that we have a 1 in front of the sine, that's our value of a, and we have a 1 in front of our x, that's our value of b. So we know that the amplitude of this graph will be 1, and we know the period of this graph will be 2 pi divided by 1, which of course is just 2 pi. Now the phase shift, which I will call PS for phase shift, is given by taking negative c and dividing it by b. Now in this problem, c is pi over 2. And we already mentioned that b is equal to 1. So the phase shift for this graph is going to be negative pi over 2 divided by 1, and that gives us a phase shift of negative pi over 2. Now, what does that mean exactly? It means the graph is going to be shifted to the left pi over 2 units, right? And it's to the left because it's a negative. So what that means, if you think about your original sine graph, and I brought that in for reference, right? Your original sine graph starts at the origin, goes up, goes down, and then back up to the middle again. So this point that is normally here at the origin will be shifted to the left pi over 2 units. So that means it's going to be here. Now, how do we get the rest of the graph easily? Well, the end of the first period is normally at 2 pi, right? It's normally here. But that value there will also be shifted to the left pi over 2 units. And since my graph is scaled in multiples of pi over 2, if we shift this value to the left pi over 2 units, we're going to end up right here. Now, we also know that the sine graph, in addition to having those 2 points at the beginning and end, in the middle of the graph, it's also crossing the x-axis. That's going to occur here now, and then it will reach its high point here and its low point here. And so if I just sketch that out here, this is what you get. Now, if I want to extend the graph, we just extend it from there. So notice that every pi over 2 units is an important point on the graph. So when we go pi over 2 units to the left from here, that's going to be a low point. Another pi over 2 units to the left will be crossing the x-axis again. And another pi over 2 units to the left, and we'll be up at our maximum value again. And so that is what it looks like to the left. To the right, if I go pi over 2 units from this point, we're going to be at a maximum value again. And that is what it looks like. So it's just one more thing on top of the other things that we already talked about. So we talked about amplitude, we talked about period. Now we're bringing in a horizontal shift or a phase shift. Our next example is very, very similar to the last example. In this case here, you'll see that A is 1 and B is 1. So we know that the amplitude is 1. We know that the period is 2 pi divided by 1, which is 2 pi. And our phase shift for this graph, remember the formula, it's negative c divided by b. C in this problem is negative pi over 2. So negative c is negative pi over 2 divided by b, and b is 1. And so this is pi over 2. So what that means is in this case, our phase shift is pi over 2 units to the right, right? Because it's positive. Now we are talking about the function sine once again. Sine normally starts at the origin, but that point is going to be shifted to the right pi over 2 units. And so that will be the beginning of our sine graph. Then we know that it goes up to its maximum value, crosses the x-axis, and then down to its minimum value. And I apologize for not having this extended far enough. Let's go ahead and add in another value here, which is 5 pi over 2. Normally our sine graph would end at 2 pi, but that gets shifted to the right pi over 2 units as well. And here is what this graph looks like. So it looks just like the sine graph, but it has been shifted to the right pi over 2 units. Now, if I want to fill in the rest of my graph here, as we move to the left, we know it's going to go to a minimum value here, and then back up to the x-axis, back up to a maximum, back to the x-axis, and back down to a minimum. So if I fill in all of those points here, graph is going to look like this. But the important thing that I want to point out is that it's the same as our sine graph, but notice that it has been shifted to the right pi over 2 units. So for our next example, it's a little bit more complicated. Notice that we have an amplitude change, we are going to have a period change, and we are also going to have a phase shift. And I'm going to show you 2 ways to approach this problem. So first of all, let's identify that A is 3, so the amplitude of this graph will be 3. The period is 2 pi divided by b, and b is this number here. So it's 2 pi divided by 2, which is pi. And now the phase shift, remember the formula is negative c divided by b, and c in this problem is positive pi over 2. So we're going to have negative pi over 2 divided by b, and b is 2. So this is negative pi over 2 times 1/2, and if you simplify that, you get negative pi over 4. And so that is going to be a shift to the left pi over 4 units. Now we are still talking about the sine graph, right? So let's remember what our basic sine graph looks like. And so normally we start here at the origin, but that's going to be shifted to the left pi over 4 units. Now you'll notice on my axis here, I don't have pi over 4 labeled, but pi over 4 is half of pi over 2. So let me come in and put some marks. So this is pi over 4. This will be 3 pi over 4, 5 pi over 4, 7 pi over 4. And here is negative pi over 4, negative 3 pi over 4, negative 5 pi over 4, and negative 7 pi over 4. So let's go ahead and label those. There we go. And in case you're wondering how I know the values of these, let's remember that since pi over 4 is half of pi over 2, this is basically 1 pi over 4. This will be 2 pi over 4, which reduces to pi over 2. This is 3 pi over 4. This next one is 4 pi over 4, which is pi. And then 5 pi over 4. So you see every mark on the graph now represents pi over 4 units, right? Some multiple of pi over 4 units. Okay, so now what we need to do is sketch our graph. We'll keep in mind the amplitude is 3, so it needs to go up to a maximum value of 3 and a minimum value of -3. We know that the original graph is going to be shifted to the left pi over 4 units, but the other really important piece here is the period is also different, right? It's no longer 2 pi, it's just pi. So our first point on our sine graph, since we're shifting it to the left pi over 4 units, that's going to be right here. And then the last point on the sine graph, remember, the distance between the first point and the last point, that distance is the period, which for the normal graph is 2 pi, but for us, it's pi. So we have to count pi units from here. Now, pi is the same as 4 pi over 4. So if I go over 1, 2, 3, 4, this is going to be 4 pi over 4 units from that starting point. So that's the end of our first cycle. Okay, so that is these 2 points on the graph. Now in the middle, we know it's going to cross the x-axis again. And then we know here we're going to have our high point, and here we're going to have our low point. But those high points and low points are going to be 3 and -3 because of the amplitude change. So the high point is up here, and the low point is down here. And this is what that first cycle looks like. Now, once you get the first cycle, all you have to do is reproduce that cycle to extend out the graph to the right and to the left. So hopefully this part is not too challenging. So after we hit our axis here at pi, we're going to be at a maximum value again. At 5 pi over 4, we'll be crossing the x-axis. At 3 pi over 2, we'll be down here at a minimum. At 7 pi over 4, we'll be at the axis again. And at 2 pi, we'll be at a maximum value again. And you should notice that when you graph it, you get this nice flow. Same thing to the left. At negative pi over 2, we should be down at -3. Then back to the x-axis, back to the maximum, down to the axis, down to the minimum, back to the axis, and back up to our maximum. And again, when you graph it, it should flow very nicely. All right, so that is what the graph looks like. Now, what some students really struggle with is they'll understand the shift. So they'll understand when I said move it to the left pi over 4 units, but they'll struggle with this point. They'll struggle with how did I figure out that it ends here? And so what I want to do is just show you another way to get this first cycle of the graph. And I really prefer using this method. So what I'm going to do here is I'm going to remind you that for the normal sine cycle, this cycle here, when we say y equals sine of x, x is a number in between 0 and 2 pi, right? This is our first cycle along the x-axis here. Start at 0, end at 2 pi. What we want to do for this problem is we want to find our new start point and our new finish point. To do this, all we need to do is instead of saying x is between 0 and 2 pi, we just take the expression inside the parentheses, which in this case is 2x plus pi over 2, and we set that between 0 and 2 pi. And then all you have to do is solve for x. So let's go ahead and solve for x and see what happens. So to solve for x, I am going to subtract pi over 2 from all 3 parts. 0 take away pi over 2 is negative pi over 2. In the middle, these cancel out and we just get 2x. And 2 pi take away pi over 2 is 3 pi over 2. For that one, when you subtract 2 pi minus pi over 2, you just need to get a common denominator. So you multiply both by 2, and that gives you 4 pi over 2 minus 1 pi over 2, and that's how I got 3 pi over 2. Okay, so that's just an explanation of how I got that. Now we need to solve for x. So the rest of what we need to do here to solve for x is we need to get rid of the 2 here. So I'm going to multiply by 1/2 here. I'm going to multiply by 1/2 here and multiply by 1/2 here. So again, the reason I'm doing this now is that these will cancel and we'll have x all by itself in the middle. And then over here, 1/2 times negative pi over 2 is negative pi over 4. And 3 pi over 2 times 1/2 is 3 pi over 4. And this is the genius of using this method, is now our new start and new finish that we were looking for are right here and right here, respectively. So this is going to be the start of our graph, and this is going to be the end of our graph. Now, when I say start and end, of course, I mean the start and end of the first cycle, right? Because obviously the graph goes on forever in both directions. So now to graph this, all I need to do is go to my x-axis and say, well, negative pi over 4 is right here. Let's put our marks back in. 3 pi over 4, remember, was this point right here. And we know that it crosses in the middle. And then we know its amplitude is 3, so we have a high point here and a low point here. And there you go. There is the first cycle of the graph. So the really nice thing about using this method is you don't have to remember formulas. You just have to remember to put the expression in here between 0 and 2 pi, and it works every time. Now, I won't finish the extending the graph since I already showed you how to extend it, but let's go ahead and go on to the next one. So here's a brief summary. When you have an equation of the form that we've been talking about here, we know the amplitude is the absolute value of A, the period is 2 pi divided by B, and the phase shift is negative C divided by B. But the really cool thing is, if you use the method I just showed you, you don't really have to remember this, right? So this last bit here is not needed if you remember the method that I just showed you. And I'm going to show you that method again when we do this problem. So I can see here very clearly that the amplitude of this graph is 2. And now I can do the start point, the end point, the period, all that, all in a single computation. What I need to do, I need to take 3x plus pi, and I need to put that in between 0 and 2 pi. So again, I'm just taking whatever's inside the parentheses, and since we're talking about a sine graph, and the normal cycle for a sine graph starts at 0 and ends at 2 pi, I'm just putting the expression in the middle here in between 0 and 2 pi. Now I just need to solve for x. So I'll subtract pi. This gives us negative pi is less than or equal to 3x is less than or equal to pi. And let's move this graph down a little bit. And then now to solve for x, all I need to do is divide by 3. And you can see what we get is negative pi over 3 less than or equal to x less than or equal to pi over 3. So this is going to be our new start point and end point. And remember, your basic sine graph goes up, down, and up again, right? So when I say start and end, I'm talking about this is the start, and this is the end. So now we just need to put all that on our graph. Keep in mind the amplitude is 2. So the sine graph is going to start at negative pi over 3, which will be on the x-axis. It's going to end at positive pi over 3. That's also on the x-axis. We know that halfway in between the starting and the ending point, it also crosses the x-axis. And then halfway in between there, at these values, you're going to have your maximum value, which is 2, and your minimum value, which is negative 2. And then if I just sketch the curve, this is what we get. So that's our first cycle. Now, if I want to extend this out, notice that every pi over 3 units on the graph, it's crossing the x-axis. So we're going to cross here, 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 right? All of these will be x-intercepts of the graph. And then the maximums and minimums occur halfway in between these values. And I don't have to label these necessarily. I could. These are all going to be multiples of pi over 6. But the important thing is that I realize to go with the flow, I am going up and then down. And then now here I will be going to a maximum again, and then back down here, and then to a minimum, and then back to here, etc. So we have this point, and then we have this point, and then this one, and this one, etc. And in the other direction, here we're going to be moving down toward a minimum value. So that will be down here, and then a maximum up here, and then a minimum, and so on. And then if we sketch that graph, this is what we get. All right, so I really, really like this other method that I'm showing you here of figuring out how to start your graph. It's just a much easier method to remember how to do, in my opinion. Let's do some more. Okay, finally we're going to look at a cosine graph. The good news here is that it works exactly the same way. So notice here that we have an amplitude equal to 2. I'm going to take my expression inside here, which is 3x plus pi, and that's going to be set between 0 and 2 pi. And we'll go ahead and solve for x. So I'm going to subtract pi from everything. And then let's divide by 3. And you can see that we're pretty much getting the same thing that we got last time, and that is x will be in between negative pi over 3 and positive pi over 3. And remember, the amplitude is 2. So now when I come down here to do my graph, it's very important that you realize that we are doing a cosine graph here. So let's bring in the cosine graph to remind you. So the reminder is that your cosine graph does not start at the origin. It starts at its high point and then goes to its low point halfway in between and then back to its high point. So on this graph, it's going to start with its high point, not at 0. It's going to start at negative pi over 3. And its high point is up at 2 because the amplitude was 2. And then pi over 3, that's the ending point, right? That's the other high point on the graph. So that's going to be here. Halfway in between the high points are going to be the low points. And then halfway in between the highs and the lows is where it's going to cross the x-axis. And so this first cycle looks like this. Now, all I need to do is reproduce that. It's a little bit trickier for this graph just because of the fact that it crosses the x-axis. Notice it crosses in between the labeled values. So it's going to cross here, 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 etc. in both directions. It's going to cross over here as well. So if I go ahead and label all of those crossing points, the x-axis, or x-intercepts, I should say, that really helps serve as a guide when I'm graphing this. And then I just need to know that it has to be a smooth curve. So notice that we have a high point here. We're going to be crossing here. And then at 2 pi over 3, we should be at a low point. And then back across, and then back to a high point, back across, etc. So if I fill in those other low points and high points, and let's go ahead and get rid of this, what we're going to have here are all these points here, and then we just need to connect them the best that we can. So notice that I'm not graphing without a guide. Notice that I'm getting the important points down first, and then graphing is much easier. Going the other direction, we have a low point here, a high point here, a low point here, high point, low point, and high point. And if I sketch this graph, and this is not a perfect graph, it doesn't have to be perfect, it just has to capture the important essence of the graph. So this is what it will look like. Okay, let's go ahead and keep going here. We have another one. This is back to a sine function again. Let's make note of the fact that the amplitude is 4. The expression inside the parentheses is 2x minus pi over 3. I'm going to put that in between 0 and 2 pi, as we've been discussing. And I'm going to show you another way to sort of deal with the fractions here. So the last time what I did is I just added pi over 3 to everything. I did something similar to that on a previous problem. You can also do this by first getting rid of the fractions. So what I can do is I can take this inequality here and I can multiply everything by 3. So I'll multiply the left quantity by 3, the right quantity by 3, and I will also multiply the middle quantity by 3. The nice thing is 3 times 0 is 0. Here, 3 times 2x is 6x minus 3 times pi over 3 is pi, and it is negative, so we have negative pi. And then 2 pi times 3 is 6 pi. So what's nice about doing this is I can get rid of those fractions. And now I simply need to add pi to everything. And after I add pi, we're going to get pi is less than or equal to 6x is less than or equal to 7 pi. And then the last thing we need to do is just divide by 6. And when we do that, we get pi over 6 less than or equal to x less than or equal to 7 pi over 6. And this is where our first cycle will be. And then remember, amplitude is 4. And we are talking about a sine graph once again. All right. So now how am I going to graph this? Well, first of all, notice that, we just have pi over 3 on the graph. We don't have pi over 6. So remember that half of pi over 3 is pi over 6. So if this is pi over 3 here, then pi over 6 is half of that distance. So this is where pi over 6 is. And so if I count by pi over 6, this is 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2. Then we have 4 pi over 6, 5 pi over 6, which is this one here. 6 pi over 6, which is pi, and then right here is 7 pi over 6. So I just want to show you that, you can figure out where those marks are on your graph. Our first cycle occurs between pi over 6 and 7 pi over 6. Remember, we are doing a sine graph. Sine graphs usually start at the origin, but now it's going to start at pi over 6. So it starts here. It's going to end at 7 pi over 6. Halfway in between, which is at this number right here, it's going to be crossing the x-axis. And then this gets a little bit tricky here. Halfway in between these two values, notice is not this number or this number. Rather, it's this value right here. You don't need to label this, but this is where our maximum is going to occur. And our maximum in this case is 4 because the amplitude is 4. So at that number, we're going to be up here at 4. And halfway in between these two numbers will be right about here, and that's where we're going to be at -4. So halfway in between those two numbers occurs right about there, and we'll line that up with -4. And let me go ahead and make those the same color. And now I can sketch my graph. And that is what it looks like. It got a little sloppy there in the end. Now to extend that, we just need to go in both directions. So if you look at what happened here, we have 1, 2, 3 multiples of pi over 6. You can see it a little more clearly here if I do this. 1, 2, 3 multiples of pi over 6. That's one hump of the graph. 1, 2, 3 multiples of pi over 6 is another one here. So as I move to the right, I'm going to go 1, 2, 3. This will be a high point. Another hump there. It's going to cross there. And then we're going to go 1, 2, 3 more. We're going to cross here. Halfway in between, we'll have a high point. That's at this value right here. Halfway in between here, we'll have a low point. And let me go ahead and sketch that in a different color. This is what it looks like. And we can take that in the other direction as well. I'll go ahead and do it off the recording, and then we'll come back to it. All right, so there it is. That's the complete graph for everything that I had labeled here. Okay, so our next one, a little bit different. You'll see why in just a second here, but we want to graph one complete cycle of this function. So we'll start by just noting that the amplitude here is 5. We're going to take that expression on the inside of the parentheses and once again put it in between 0 and 2 pi. And I'm going to solve for x. I'm going to start by multiplying everything by 4. That's going to give us 0 here, less than or equal to 4 pi x plus pi, less than or equal to 8 pi. Double check everything there if you want. Subtract pi from all 3 parts. This gives us negative pi, less than or equal to 4 pi x, less than or equal to 7 pi. And finally, to solve for x, I need to divide by 4 pi, right? Because I'm trying to get x by itself here. And so that gives us x is in between 7/4 and -1/4, right? Because these pi's here cancel out. And remember, the amplitude is 5, and we are doing a sine graph. So what that means, if you look at our graph down here, conveniently, we do have force on our graph. This is 1, so this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Okay, so this point right here is 7/4. -1/4 is this point here, so that's the beginning and end. Halfway in between is at this point. And then halfway in between again, which will be right about here, we're going to have our maximum value because it's a sine graph. And halfway in between these two, which is at this point, we will be down at our minimum value. And then we just sketch the graph. And again, the graph doesn't have to be perfect. We're just trying to capture the essence of the graph. So notice how quickly you can do this when you start to get the hang of finding that first cycle. Now let me go ahead and fill the rest of this out. And basically, I just want you to notice that, every 2 marks on the graph, you have an important point. So here we have an x-intercept. If I go 2 marks to the right, we're at our high value. If I go 2 more marks, we're at our x-intercept. 2 more marks, we're at our minimum value. 2 more marks, we're at our x-intercept again. So if I go 2 more marks to the right, we're going to be at our high point. 2 more marks will be at our x-intercept. 2 more will be at a minimum. And 2 more will be back here again, and that's what this looks like. And we can do the same thing in the other direction. And there it is. The last example is going to talk about the only thing left to talk about. So we have discussed how to change the amplitude. We have discussed how to change the period. And we've discussed how to do a phase shift, a horizontal shift. We just got done doing all of that. The only thing that's left to do is a vertical shift. So when you add a number or subtract a number to the function, you are going to get a vertical shift by that amount. Now, it says here, use the graph from example 7 to help you sketch the cycle for each one of these. So I just want to point out that the graph that you're looking at right here is the graph that we just did in this other problem. It looks a little different because our scaling is different, but I want you to notice that the function here is identical to what we have over here. Oops, sorry. Right? That part of the function is identical. So if we know that this part looks like this, the only thing that this plus 3 is going to do is it's going to shift the entire graph up 3 units. Okay? So we'll go ahead and graph this first one here. We'll do this in green. And if I'm going to shift it up 3 units, basically all you have to do is take every important point. So take all the high points, the low points, and the x-intercept points, and shift them all up 3 units. So if I go up 3 units, that'll be here. If I go up 3 units, that will be here. Up 3 units will be here. Up 3 units is here. And up 3 units is here. Okay, now I'll get rid of all those little arrows so we can see it a little bit easier. And now all we have to do is sketch through those points. And then we can do that for the entire rest of the graph. And this is what it looks like. And so this graph here is y equals 3 plus 5 times the sine of pi x plus pi over 4. Now let's graph this one, and we'll do it in blue. Actually, let's do it in red, sorry. This is going to move that same original graph, which is this graph here, but it's going to shift it down 5 units because we have a negative 5. So to get that graph, I'm just going to take every important point on this graph and shift it down. And there are all those important points. And now if I just connect those, you'll see that this graph looks exactly the same as the original graph, except that it has been shifted down 5 units. Every point was shifted down 5 units, including this point over here. Okay? So vertical translations aren't that hard to do, but when you're starting from scratch, when you don't have any graph at all to look at, basically what you're going to do is you're going to find out where that sort of that new x-axis is. All right? So we'll do one more example here just to kind of show you what I mean. So let's suppose I wanted to graph y equals 2 plus cosine of 2x minus pi. So I'm going to start by doing the same stuff I always do, which is I notice that the amplitude here is 1, right? So we have to look at the number in front of cosine. And then we know that our first cycle is going to occur when 2x minus pi is between 0 and 2 pi. And I need to solve for x here, which I'm going to do now. And when you solve this for x, you end up getting x is between 3 pi over 2 and pi over 2. So that's going to be your start and end point, right? So we got our start, we got our end point, we have our amplitude, but there's also a vertical translation, right? A vertical shift up 2 units. So the way I like to take care of this is remember that the cosine graph normally oscillates around the x-axis. Well, since everything is shifted up 2 units, the x-axis, in a way, is also shifted up 2 units. So I'll go to the number 2, and I will draw a horizontal line there. And this is what I often like to call my new x-axis. It's not what it is, but it's what I like to call it, because what's going to happen now is your cosine graph is going to oscillate around that line. Now, the amplitude is 1, so that means that you're going to go up 1 unit from 2, which is to this value, and you're going to go down 1 unit from 2, which is to this value. So your entire graph is going to occur between those 2 blue lines, between these lines here. So now what's really nice is all you have to do is go to your start point. Your start point is at pi over 2, which is here. Your end point is 3 pi over 2. And we're doing a cosine graph. We know that cosine graphs start at the high point, they end at the high point, and halfway in between they're at the low point. And halfway in between the highs and lows, it should be crossing this middle line here, which is right about here and right about here. And so this is what that first period is going to look like. And then from there, all we have to do is reproduce that all the way across. So I'll go ahead and put in all the important points, and then we'll take it from there. And just to note, all I'm doing here is I'm putting in my highs and lows, because with those you can get a pretty good graph. So I'm just going to sketch down to my low, up to my high, down to my low. Same thing in the other direction, down to the low, up to the high, down to the low, etc. And that gives us our graph. So again, what I'm doing here is I'm recognizing that the vertical shift is 2 units, and I'm coming in and I'm drawing that line y equals 2 first. Because when you draw that line, it just makes everything easier to see from there, because you're basing everything off of that middle line.